I'd like to show you an example of levitating small objects with sound waves. Let me just remind you how a loudspeaker works. It's just a diaphragm that repeatedly pushes on the air, producing high pressure waves that move away. And that's what we have here with this little gizmo. It does the same thing, except it's at a very high frequency, 28,000 hertz, which is way above our human hearing range. So these sound waves move upward, and up above I have a glass plate which is going to reflect the sound back down again. And when the distance between the glass plate and the loudspeaker is just right, then those sound waves that are moving down will interfere constructively with the sound waves coming up and give us regions of high pressure and low pressure which don't move around. They stay in one spot. And it's in those high pressure zones that I'm going to try to levitate a small ball. So let me turn on the power, and even though I can't hear it, I'm still going to use ear protection. As I said before, the distance between the reflector and the loudspeaker is just right. If I change it, and which I'm going to do, you'll see that this standing wave disappears and the balls are no longer suspended there. We've now set up the little loudspeaker and the reflector in front of this mirror, which is part of our Schlieren optic setup. And the purpose of that is to be able to actually see where there are regions of high pressure and low pressure in the air, especially the air between the reflector and the loudspeaker. So let me turn up the volume, and before I do that, I will put on my protective hearing. And if I adjust the height of the reflector, there's a point at which you see bands of white, light, and dark. This is the standing wave, and it only happens when the distance between the reflector and the speaker is some multiple of a half a wavelength. So every single one of those bands is a half a wavelength. If I go up a little higher, then it disappears again, but if I continue to go higher, then it will come back when I'm at another half a wavelength, a multiple of a half a wavelength away. Now, it's in these bands that I'm going to place the little balls. And you can see the little ball settles down where there's a bright band, and that is the high pressure area. And I know it's a high pressure because you see there's a white band right next to the reflector, which is where the highest pressure will be. If I again change the height, the standing wave goes away and the little balls will fall down.